Hi, welcome back to Allen High School. We're talking about electrochemistry and balancing reactions. I want to do one more somewhat straightforward one. It's a step harder than the last one we did, and then two in acid solution in this video. So step one is to assign oxidation numbers. I do it quickly. We don't have time to belabor this. So if you're having trouble with these, make sure you ask for more detailed help in class. Okay, so this is -8 plus 1 gives out a +7. So hopefully you can see that. Now, what I'm going to do is I'm going to zero in and just, focus my attention on those substances that changed oxidation number. I'm not, breaking bonds. I'm just focusing. So let's first take a look at our manganese. So manganese went from an oxidation number of +7 to an oxidation number of +2. That is more negative, so I have to give it the negative. 5 negatives plus 7 is +2. So my charge is balanced, as well as we're going to work on our electrons here. Now, Cl negative went to Cl2. Now, notice that not all of it changed, but at least 2. So I'm going to have multiples of 2. It's going to be 2, 4, 6, 8. All right, so I'm going to put my 2 there and go ahead and balance that little subscript. Now, that became less negative, so it lost 2 electrons. I need to balance electrons. The least common multiple of 5 and 2 is 10. So I'm going to multiply those out. I'd have 10 electrons plus 2Mn7 plus 2Mn2 plus, and 10 chlorides. All right, so we've got electrons balanced, we've got charges balanced, and so now we have to put these subscripts up into the equation. Now, I have 4 possible subscripts. Whoops, I forgot my 5 there. 4 possible subscripts to use. You'll get 3 of them to go up into the reaction pretty readily. Often the 4th is not going to go into it readily. So let's take a look. 2Mn7 pluses. Ask yourself the question, is this the only place it showed up? And did all of it change? And the answer is yes. So I'm going to put a 2 there. Is this the only place it shows up on the left-hand side? Yes. But not all of it changed. All this represents is this chloride that was oxidized. There's some chloride that wasn't, so I can't put that 10 there. I can put the 2 here, because that's the only place it shows up. And this is the only place Cl0 shows up, so I can put the 5 there. So get 3 in there. Once you're done, it's easy to balance. Right? This would be, I bet you'd take you a half hour to balance this if you didn't do this method. So I have here, let's see, I'm going to balance my chlorides. I've got 10 there. I've got 4 there. So I've got 14. I need 14 chlorides. That gives me 14 hydrogens plus 2 hydrogens is 6. So I need an 8 there. Okay, let's go on to the next one. You see I'm going camping tomorrow. My little reminder came up as if I didn't know. Okay. Now, there are times when you're given even less of a skeleton to balance. And all the instructions will say is, here's the heart of the matter, here's the heart of the changes, and we're doing it in an acidic solution. So let's see what we do. Again, you assign oxidation numbers. Okay, so there's my oxidation numbers. I'm going to zero in on these things that change. Copper was oxidized. Nitrogen was reduced. Okay, so it's going to gain an electron. The lowest whole number ratio is 2. So I've got 1 here, and it's okay to put a 1 in there. I like to put my 1s in at this point as a reminder that I can't change those numbers because I'll change the number of electrons involved. A 2 here and a 2 here. So I've balanced my skeleton, but I haven't balanced my elements yet. So let's see what we do. The first step you do is you balance your oxygens with water. Now, wherever you're deficient oxygens, you may be deficient on the reactant side, or you may be deficient on the product side. So don't think they have to go on one side or the other. There's no magic to that. Just put it on the deficient side. So this side has 6 oxygens. This side has 4 oxygens. So I'm deficient by 2 oxygens. So I'm going to add 2 waters. Okay, so right, 6 minus 4 is 2 oxygens. So that means I then balance the hydrogens with H+. So I have 4 hydrogens here, so I'm just going to put 4 H+ on the other side. And now it's balanced, at least as a net ionic. Let's take a look at the next one. It's slightly trickier. Okay, this is one with dichromate in it. And I thought I put in a new slide for dichromate. There it is. Okay, let's take a look at how we would balance the dichromate. I've got -2, so that makes this a +6. That's -1. That's a +3, and this is 0. So let's first, and you know, check me very carefully on this if you would, please, because I don't have this written down in front of me. So the chromium, at least 2 of them, so I'm going to bring that 2 down. Go to chromium 3+. It might be 2, it might be 4, it might be 6, it might be 8, but it's not going to be an odd number. Now, the chromium became, it went from +6 and 2 of them, so that's actually a total of +12, right? 12 positives between those 2 CRs. Okay, and that's a +6 on this side, 2 times the 3+. So I'm going to need 6 electrons. Okay, so that's 12 positives minus 6 is +6. Each one went from +6 to +3. That's 3 electrons. I'm looking at 2 of them, so that's 6 electrons. Just showing you where I'm getting those numbers. Okay, chloride went from Cl- to Cl2. Again, at least 2 of them. And that's going to be +2 electrons. Now, the lowest whole number ratio between 6 and 2 is 6. So I'm going to multiply that by 3. I'm going to multiply this by 1. Okay, got to get rid of this up here. It's in my way. Okay, so that means I need 1 in front of here. I'll need a 1 times a 2. I'll need a 2 in front of that chromium, right? This is a 1 times a 1. Okay, I need 3 times 2 of the chlorides. This is the only place it shows up, so I'll need 6 chlorides. I'll need a 3 times a 1 for the Cl2, so I need a 3 here. Okay, so now our electrons are balanced. Now what we have to do is balance oxygens. This side has 7 oxygens, whoops, and this side has 0 oxygens. So I'm going to have to add 7 waters to make up for those 7 deficient oxygens. And that means I'm going to add 14 H pluses because we're balancing in an acidic environment. Okay, so that's all you do there. All right, that's all for now, kiddos. Talk to you later.